Good morning, everybody. We're going to go ahead and move on to Chapter 11, Standard Costs and Variances. The first thing we need to discuss is what are standard costs. Standard cost is a term we use in the budget process to represent a single unit of product. How much did that one single unit cost? We call it, we refer to that cost as the standard cost. We develop a standard cost for each type of product. So if we produce many different types of products, we're going to come up with a different standard cost for each product. Service companies use standard costs as well, although a service company will be looking at jobs, the specific jobs and what those jobs cost, especially if it's repetition in nature, if it's the same type of job that they provide. And the standard cost becomes a benchmark for evaluating actual costs. There are different types of standards. There's the ideal standards. And when we're talking about standards, we're talking about budgets, we're talking about estimates, we're talking about people trying to figure out before you produce the product how much something should cost, or what would it normally cost. And so when you have an ideal standard, it would be based on perfect or ideal conditions. What would this product cost me if everything ran smoothly, if everything is perfect? Perfection standards, I guess that's the next level, is do not allow for any poor quality raw materials, any waste, any machine breakdown, or other inefficiencies. So I guess we'll go back to ideal standards. You could say that's a ideal situation. And I think these terms can be used interchangeably, but if you're going to use the term perfection, then you're really throwing out any kind of problems that you may have with your production process. And then we come up with what's often referred to as the practical or attainable standards. And this is based on currently attainable conditions. So what do we expect to produce based upon our production systems? We're going to have to give some kind of allowance for human error, for machine problems, slowdowns, things that are out of our control. You have to have some level of acceptance of that. Otherwise, you create standards that are just so unreal that, and then if you're going to use those standards as a base of performance, employees are going to get really frustrated with that because it's like, there's just no way I can do that. So why are you holding me to that standard? Okay, so how do we come up with these standards? I mean, we can actually come up with these standards both before, during, and after production. We're going to use past material and labor usage, so we'll use information from the past. We use current inputs, so if prices change or if different things are occurring, we're going to adjust our levels of what we've come up in the past and make adjustments based upon current information. Then we're going to estimate the future. We're going to figure out, well, if things change in the future, let's incorporate that into our standard cost. What we're trying to get is the time and quantity that should be needed to produce each unit. So we're going to use past information, current information, and future information based upon our best guess of the future. Okay, so a standard cost system is going to be the preparation of standard costs for direct materials, direct labor, and manufacturing overhead. And then more specifically with manufacturing overhead, we're going to be looking at variable and fixed costs. So let's first go to direct materials. So either based upon studies or what we know that's going on today, we're going to figure out, well, how much quantity of our raw materials is necessary for the product that we're producing. So I'm going to go ahead and use this mouse here as an example. And I know we've talked about this in class, but this is primarily made up of, especially the shell, let's just focus on the shell, is primarily made up of plastic resins or plastics. Now, there's the way you buy these plastic resins, they come in large containers, sometimes truckloads, sometimes even rail car loads. And you pull them out and you put them into these injection molding machines, and these machines heat them up, heat the plastic so that it's liquid, and then you have these molds that really have the shape of the plastic part, and the liquid plastic is shot into these molds, and they form the shape of what you want. Okay. So for every one of those mouses, how much plastic do you need? Well, you can do that in terms of weight. You can do that in terms of size if you're using different types of materials. But for the plastic resins, you're likely going to be using weight. How much? Because you buy it in pounds anyway. But and then if we're going to use the example that's being used in the textbook, Tucson tortilla. Well, to produce tortillas, you know that you're going to need flour. Flour is the base ingredient of tortillas. And so Tucson tortilla uses 5 pounds of flour. At what? Well, the standard quantity. So we know based upon historical information and how it's all worked in the past that it takes 5 pounds. And based upon what the standard price is of $1.50 per pound, we could use what we paid in the past. We could use what we're currently obligated to pay, or even what we're projecting we're going to pay in the future. But we've come up with $1.50 per pound. So our standard quantity is 5 pounds at $1.50 per pound. That's pretty simple. Standard quantity times the standard price gives us the standard cost for direct materials. Now, when we say the standard quantity, it's 5 pounds of flour for every case that we produce, every case of tortillas. So with every case of tortillas, it takes 5 pounds. So what we're really looking for is what's this really costing us per case? So we're going to take 5 pounds of flour, we're going to multiply it by $1.50 per pound, and that's going to give us $7.50 for every case of tortillas we produce. For direct labor, we're going to do something very similar. We're going to come up with the standard quantity of direct labor, but we're not going to be measuring these in pounds or ounces or anything like that. It's going to be based upon time. So how much time does it take of direct labor? Remember, we're talking specifically about direct labor. These are the production line people. How much time does it take for a direct labor person or persons to produce 1 case of tortillas? Well, according to the future, the past, and the present, we have come up with 0.05 direct labor hours for every case. 0.05 direct labor hours per case. Now, what does it cost us per direct labor? Well, let's say when we take into consideration the wages, the overhead, employee overhead, the benefits, it ends up costing us $22 per hour. So for every case, 0.05 direct labor hours and $22 per hour. So every case is going to cost us 0.05 hours times $22 per hour, and that's going to give us $1.10 per case. Then we're going to go over to manufacturing overhead. And what we're going to do with the manufacturing overhead, we've got to take it into 2 parts. The first is the variable cost. So what we're going to come up with is the total estimated variable manufacturing overhead. This is all based upon a budget that we come up before we do our production runs for the year. And this is what we also have to remember when we're coming up with these standard costs. We're coming up before the year even starts. We're doing this before the year actually starts. It's likely going to be part of our budget process for the following year. So we're coming up with the estimated variable MOH. We're going to look at our budgets. We're going to divide that by the total estimated amount of the allocation base. And we've talked about an allocation base. Could be direct labor hours. It could be machine hours, whatever it may be. And then we're going to take that allocation base, or we're going to take this computation, and that should be equal to the variable MOH rate. We're coming up with a rate. We've done something similar before, so this shouldn't be very new for us. Once we've got that MOH rate, we're going to take the standard quantity of allocation base, and we're going to multiply it by the variable manufacturer overhead rate. And that's going to give us the standard variable MOH per unit. We're going to go now to our fixed costs. We're going to get our total estimated fixed MOH, just like we did our variable MOH. It's our total estimate. This is part of the budget. We're going to divide that by the total estimated amount of the allocation base. We may use the same allocation base. We may use a different one. We have to figure that out. But when we do this computation, we're going to come up with a fixed MOH rate. And then our standard quantity of the allocation base times the fixed MOH rate, which is what we came up here, will equal the standard fixed MOH per unit. Okay. So the easiest way to do it is to just look at numbers and see how they flow through. Tucson allocates MOH using machine hours. Each case requires 0.10 machine hours. So our allocation base is machine hours, and each case requires 0.10 machine hours. Tucson plans to produce 400,000 cases. Using 40,000 machine hours, how do we get 40,000? Well, 400,000 cases. Each case requires 0.10, so we take 400,000 cases, we multiply it by 0.10, we're going to come up with 40,000 machine hours. Tucson expects $1 million of variable overhead, MOH, and 360,000 of fixed MOH. Okay. So the first step, let's come up with our variable costs per case. We come up with $1 million of variable overhead, variable MOH. Divide that by the 40,000 machine hours that we're expecting for the year. And that's going to give us $25 per machine hour. Mind you, just so that we're clear, Tucson plans to produce 400,000 cases. That's the plan, and that could be for a full year, all right? It's for a full year. So for the full year, we're going to be using 40,000 machine hours. That's what makes this all work, because we're projecting an entire year, and now we're going to come up to a rate per machine hour. So $1 million of variable manufacturing overhead, MOH, divided by the 40,000 machine hours, because that's the allocation base, that's what we're going to be using, gives us $25 per machine hour. We're going to take the $25 per machine hour, and we're going to multiply it by 0.10 machine hours, and then we're going to come up with what each case costs. Remember, each case requires 0.10 machine hours. So 0.10 multiplied by $25 per machine hour gives us $2.50 MOH per case. Now we have our $2.50. Now we have the cost per case, right? That's for variable. We're going to review or do the same thing for fixed, except for fixed, we're going to use different numbers. Our total fixed cost, MOH, that we're projecting, this is for the entire year, is 360,000. We're thinking we're going to have 40,000 machine hours for the next year, so we're projecting 360,000 divided by 40,000 gives us the $9 per machine hour. That's a projection, that's the rate we're going to use. And then we're going to multiply that $9 per machine hours times the number of machine hours per case. Each case requires 0.10. So 0.10 multiplied by the $9 will give us $0.9 of MOH per case. So we have our rates now. We have our $2.50 MOH per case for variable costs, and we have our 90 cents MOH per case for fixed. So we're going to put this all together. The standard cost of one unit includes the direct materials. If you go back a few slides, you'll see we came up that it costs us, or it requires 5 pounds for every case. We multiply that by the standard price. These are all projections. We're all doing this on the front end before the year even starts. 5 pounds times $1.50 per pound, $7.50. Our direct labor, 0.05 per case of direct labor hours. We're going to multiply that by $22 per case. We actually did these already, but we're putting it all together, and we're going to using a spreadsheet here so that we could summarize everything in this whole area. So direct labor, 0.05 direct labor hours times $22 per direct labor hour equals $1.10. Variable manufacturing overhead, that was the previous slide, 0.10 times 25 gives us $2.50. And then fixed MOH is 0.10 machine hours times $9 per machine hour, and that's 90 cents. Everything we just figured out in the last few slides, we add them all up. 1, 2, 3, 4, 4 items. The 4 elements of product costs are then added up so that our standard cost for one case is $12. Now we have the basis by which we measure our actual costs to judge or determine whether or not we're meeting our standards. We incorporate sustainability and standards, or we merge sustainability and standards. Companies are re-engineering their products, packaging, and production process to do a number of things, certainly to save in cost, because companies are always looking for ways of doing things better and faster and saving money. But also in terms of sustainability, we're looking for ways of doing things to save environmental resources and money. When we're doing this, when we're making changes to our products or production process, when I say re-engineering, that's especially our production process. Instead of moving this machine to this spot, we're going to move it over here, or replace that machine because we have another machine that works better than that, faster, stronger. We're just that's the reference to what re-engineering really means. All right. But when we do these kinds of things, when we end up making these changes, that's going to result in changes in the MOH standards. So we got to do recomputations once we know we've made changes. It also, our operating costs and standards also will change, and the life cycle standards, the environmental impact of consumer use and disposal. So we're looking at standards as a way to also incorporate sustainability. All right, so once we've got the standards in place, now we can use it to develop the flexible budget. Flexible budget is what we learned in our previous chapters. Assume Tucson produced 31,000 cases, even though it planned for 29,000 cases. So now this is into the first month or two or whatever it is. Now we're in the production process. And we've actually produced 31,000 cases. We thought we were going to produce 29, but we ended up producing 31. So we're going to use the flexible budget to really determine whether we met standards or we met our objectives. So we're going to look at direct materials, direct labor, and manufacturing overhead. Those are the ones that are variable related. So the standard cost for each one of these, direct materials was $7.50 per case. Direct materials was $1.10 per case, and variable manufacturing overhead was $2.50. We came up with these numbers. Okay, our actual cost for 31,000 cases was $224,000 for direct materials. That's what our product costs. That's what the items that we use for direct materials cost. Direct labor, this is the amount of money we paid out to our employees. And then our variable manufacturing overhead, which includes all utility costs, janitorial costs, utilities, all the variable costs that we have under MOH, manufacturing overhead. These are the actual costs for 31,000 cases. Our flexible budget now for 31,000 cases, we're going to use the standard cost per unit and multiply it by 31,000 cases. So $7.50 multiplied by 31,000 cases gives us 232,500. $1.10 multiplied by 31,000 cases gives us $34,100. And $2.50 multiplied by 31,000 cases gives us $77,500. So these are the flexible budget dollar amounts that now this is what we're going to use to compare to our actual to determine whether or not we are doing well in it. For direct materials, our actual costs were $224,000. Our flexible budget is $232,500. The difference between these two resulted in $8,500. And because our costs, our actual costs were less than the flexible budget, that's considered to be favorable. For direct labor, our actual costs were $34,875. The flexible budget called for $34,100. Whoops, we were over budget by $775. That gives us an unfavorable variance. And then the variable manufacturing overhead for the cases, our actual costs were $85,200. The flexible budget called for $77,500. The difference is $7,700, and we spent more than what we had budgeted for, so we have an unfavorable variance. Okay, so we came up with a flexible budget variance, but we really can split the flexible budget variance. The flexible budget variance, we know that we were favorable. We can actually split that up to get a little bit more information or more detail about that variance into two variances. One is referred to as the price variance, and the other is a quantity variance. Okay, so in other words, this 8,500 favorable variance that we computed based upon the previous slide for materials, that 8,500 is really incorporating both a direct material price variance and a quantity and a direct material quantity variance. So if we break this down in a little bit more detail, we can get a better understanding as to what our real costs are. So if we have, that was a break. So if we have the 8,500 favorable, we can break it down into further detail to understand how much of it is associated with the price and how much of it is associated with quantity. So what we're going to do is we're going to come up with this kind of three-prong approach. And this is repetitive in nature. So once we figure out how to do it for one of these, you'll figure out that it really kind of follows a pattern for all of these. At first, it seems a little bit more complicated than what it really is, but just kind of hang in there and you'll figure it out. So on the far left, I want you to think that we've got these three sections here. 1, 2, 3. On the far left, these are the actual costs. Okay, focus. These are purely actual numbers, pure actual. On the far right, this is pure budget, pure standard, the purest it can be. Okay, pure actual, pure standard. Okay, in between, we kind of have a combination. Okay, combination of both actual and standard. It's kind of an element of actual here is pushed here, and then a standard's pushed here. So if we can remember this, the way I remember just when I was learning this is just figure, okay, the left side is actual, and the right side is pure budget. In between is kind of a combination of the two. Okay, so our actual cost, that's going to be actual quantity multiplied by the actual price. Actual quantity multiplied by the actual. That's pure actual costs. Okay. So what we're going to end up coming up with is this is going to filter into here. Actual quantity, actual price. That's the line here. You can see that, that's right. Now we're going to compare this to this. This is the actual quantity. So, okay, AQ is still involved, AQ, but now we're going to add the standard price. So we're going to take the standard price here and move that over here. So we're comparing these two areas, and we're coming up with the actual quantity times the actual price. That comes from this. And we're going to subtract from that the actual quantity times the standard price. So really, if you think about it, the only thing that's different, since they're both actual prices, we're really looking at comparing actual price to the standard price. And for that reason, we call this the price variance. You can use distributive property to then figure that since there's AQ is similar in both, we can come up with this distributive property formula of AQ time, open parentheses, AP minus SP. So the difference between the actual price and the standard price multiplied by the actual quantity, that's going to give us the direct material price variance. Now we're going to look at our volume variance, or our quantity variance, and we're going to look at this and say, okay, what's the quantity variance? Same kind of deal. We're going to use AQ times AP, the actual quantity times the standard price, and we're going to compare that to the standard quantity allowed times the standard price, standard quantity allowed times the standard price. Now the standard price is the same. All we're really looking at is the actual quantity versus the standard quantity allowed. Okay? Or we can modify this using distributive properties to come up with a modified formula of SP multiply, open parentheses, multiplied by AQ minus SQA. And that is going to give us the direct material quantity variance. Whatever this result is, and whatever this result is together is going to give us our total direct material variance. Let's take a look at the specific numbers. Oh, no, I guess not. So here's kind of a breakdown. This is kind of a breakdown of direct materials price variance, how we came up with this. This is, from the previous slide. That's this formula. And then the direct materials quantity variance is this formula. So if you just wanted the formula, just give me the formula. That's all I want. I don't really care how we got it. Those are the formulas. AQ, open parentheses, AP minus SP, and then SP, open parentheses, AQ minus SQA. The way you learn this is by looking at examples and following patterns, okay? So using the following information and Exhibit 11-2. The number of cases produced was 31,000 cases. That's what we know. That was given. Now we're going to be given, well, how much direct materials were purchased? It turns out that 160 pounds at $1.40 per pound, that was what was purchased. The amount used was 160,000 pounds. Okay, so this is the information that we're going to be using. Now we'll plug it into that graphic that we learned about earlier, and we're going to plug in the numbers. So the actual cost is going to be the AQ, actual quantity, we were given this 160,000 pounds, and the actual price. That's all. The actuals have to be given to us. And we come up with 160,000 times $1.40, 224,000. We'll go to the actual quantity and the standard price. The actual quantity, well, that's the same as the AQ is the AQ. It's the same. It's 160,000 pounds. Times the standard price, $1.50. Well, we computed that earlier in the previous slides when we come up with the direct material standard price. It's $1.50 per case. I'm sorry, $1.50 per pound. So 160,000 pounds times $1.50 per pound gives us 240,000. And then we're going to go ahead and fill in the numbers here for the standard cost allowed. Standard quantity allowed. Since we used 31,000 cases, since we produced 31,000 cases, we're going to multiply that by the 5 pounds. That's the standard amount or quantity used per case. We're going to come up with that computation first, and then we're going to multiply it by the standard price. The standard price is the same as the standard price. It's $1.50. If we run these numbers, we're going to come up with a total of 232,500. Just use your calculators to run those. 232,500. Okay, now we have the base amounts we can compare. We're going to compare 224,000 to 240. That difference is $16,000 favorable. $16,000 favorable. If we have $16,000 favorable, that accounts for some of it. But now we're going to look at comparing the quantities so that we could come up with a quantity variance. It turns out that we ended up having an unfavorable quantity variance. Now, this is kind of important for us to know because we ended up with an $8,500 favorable variance. But when we looked closer to it, we found out that of the $8,500, we really had a $16,000 favorable variance for pricing. So kudos to our purchasing department because they found product that was less expensive than what we anticipated. But this somewhat masked the fact that our production runs were not running so well because we were expecting, if you think about it, we used 160,000 pounds. Based upon 31,000 cases, let's go ahead and run those numbers. 31,000 cases times 5 times. We actually used we actually used 160,000 pounds, but if we compute this number, 31,000 times 5, we should have used 155,000 pounds. 160,000 pounds is what we actually use. The standard quantity allowed is 155,000. Well, 155,000 compared to 160, we use 5,000 cases more, or pounds, I'm sorry. We use 5,000 pounds more than what we should have. What happened to the 5,000 pounds? Did we have machine breakdowns? Do we have people coming up in their trucks and loading materials and taking off with it? That's investigative. That was masked by just simply looking at the $8,500 favorable variance. When we broke it down between a direct material price variance and a volume variance, or rather quantity variance, that tells us that we were at $7,500 unfavorable. I want to know why. Now we're going to look at our production people and say, what's going on? Why did we use more than what we expected? Okay. Actual costs. We had a direct material price variance of 16,000 favorable, 7,500 unfavorable. Total direct materials flexible budget variance is $8,500. So you net these two because one is favorable and one is unfavorable, so you can net those two. And because 16,000 favorable is higher, that gives us the 8,500 favorable. In the previous example, our amount purchased was the same as the quantity used. That's not likely going to happen. Where you're going to have changes in inventory levels because it would be pretty coincidental if what we purchased was exactly what we used. So what we have to really be prepared for is when that number differs. Let's take a look at what happens. Direct material price variance will be based on the quantity of the direct material purchased. So just to be clear, the price variance is based upon purchased amounts. The direct material quantity variance will be based on the direct materials used, okay? Not the purchased amount. So in other words, we need to know both of these. Purchased will apply to the price, used will apply to the quantity variance. When that occurs, the direct material price and quantity variance will no longer sum or net to the total flexible budget variance. So that kind of makes it a bummer. We can't double check things because when the amounts used and the amounts purchased are different, then we're not going to be able to use the flexible budget total to be able to verify the numbers. So here's an example of the direct material variances when quantity purchased differs from quantity used. The number of cases produced, 20,000 cases. The direct materials purchased, 105,000 pounds at $1.45 per pound. Direct material used was 98,000 pounds. In this example here, there's a difference. So we're going to run our direct material price variance, 105,000 pounds, multiplied by $1.45 per pound minus the $1.50 per pound. So the $1.50 was the standard price. Here's what our actual price is. This is the formula that we learned before for the direct materials price variance. You can flip back to a number of slides to see, but that's the formula. The difference, this difference multiplied by 105,000 pounds gives us a favorable variance of $5,250. Our quantity variance, though, is not based on the amount purchased, but on the amount used. So we use 98,000 pounds. What we should have used based upon 20,000 cases, 20,000 cases multiplied by 5 pounds per case, that's just by looking at it, you know you have 100,000. So we should have used 100,000 pounds. We ended up using 98,000 pounds. That difference is 2,000 pounds. And 2,000 pounds multiplied by $1.50 gives us 3,000. Now, we were expecting to use 100. We only used 98, so that means we had a favorable variance.